Each one has a slightly different implementation of the data cube. And so we'll start with Greg Giuliani from UNEP Grid in Geneva, and he'll be telling us about the Swiss cube. And then Miguel Morgado will talk about Uganda and the UK effort. And then finally, Pilar Lozano Rivera will be here momentarily, but she'll tell us about the Columbia cube. So you'll see that each one has a slightly different path and a slightly different place that they are in the development. And take it away, Greg. Welcome.
It's a pleasure to present the outcome of 1 year of work around this Swiss data cube that we're implementing for the Swiss government. So my name is Gregory Giuliani. I'm working at the University of Geneva, but I'm also sharing my time with UNEP Grid, so the UN Environment, and GRID stands for the Global Resource Information Database. So we are, I would say, the geospatial and Earth observation arm of UNEP. And within this frame, we have the GRID has a special agreement because this is a tripartite partnership between the University of Geneva, the Swiss Federal Office for the Environment, and the United Nations Environment Programme. And within this frame, so we are doing a lot of Earth observation for supporting UNEP in this reporting process on the environment. And I will give you first a short introduction on what we've done so far before the data cube, the Swiss data cube, and where the idea comes from our perspective. So in 2000, UNEP released this really nice report called One Planet, Many People. Yes, it's an atlas of the changing environment. And the basic idea was just to take images, Landsat images from the archive and just to compare them within a time frame, let's say, of 20 to 30 years. And we're just giving some explanation. So in this case, for example, it's in southern Spain. So this is the Almeria region where there is a huge land cover change, because now there are a lot of plantations there for feeding European with strawberries during the entire year, basically. So that was the report. And UNEP set up a web-based platform in the year 2000, highlighting all these sites, of more or less 200 sites around the world. So these are still available, I guess, on Google Earth. So you just click on one of the UNEP logo, and then you basically have the two images with the explanation. And 3 years ago, so the UNEP headquarters, our director told us, okay, so we have to update those 200 sites around the world. So we start with our team to brainstorm a little bit on what we can do. And one of my key area of interest is merging Earth observation with the SDI and standardized OGC standard technologies. So we came up with a solution. This is called the live monitoring of Earth surface, or in short, LIMES. So this is a full methodology. So it's a chain, a processing chain using the WPS standards, so that we were able to gather all the Landsat data coming out from the USGS archive and try to monitor those sites on a continuous basis. So we automatized the full, I would say, pre-processing and processing chain as a whole. So we did some experiments on 5 of those 200 sites. So this is the map. So you recently have a paper that has been published explaining the entire methodology. But basically, it was we need to automatize this processing chain. So coming from downloading the images, doing all the pre-processing steps, and ideally also compute some indices, and then release the indices or the information product using the OGC standards, so that we are able to monitor on a continuous basis several sites around the world. So the web platform allows you to compare the least recent image with the most recent image, well, the oldest image with the most recent image. You can compare through time also the data. So this was 3 years ago for us, a little bit the state of the art for UNEP in environmental monitoring using Earth observation. And we engaged, at the same time we were approached by the Swiss government telling us, well, we need to use Earth observation for monitoring Switzerland. So last year, we received the mandate from the Swiss government just to make a kind of feasibility study on using the DataCube approach. So we said, oh, okay, we have the LIMES platform, but we have to go one step further. So that's why we had the opportunity to engage with CIOS, and I really want to thank Brian and his team because they were really supportive from the early stage of the generation of the Swiss DataCube. So the basic idea of this feasibility study was to take 5 years and to see how it works, and so come up with some recommendation to the Swiss government. So we've been supported by GeoGeos, by CIOS, by Geoscience Australia, and really thank you, Brian, and all your team for your work. So in the background, the Swiss DataCube team, so I'm coordinating from a technical point of view the Swiss DataCube. From the institutional point of view, this is my colleague Pascal Peluzzi. We have a colleague taking care of the infrastructure, a colleague taking care of the data preparation, and 2 colleagues about data ingestion and analysis. This year, basically, we had a small cube with 20% of the Landsat data covering the country. So we come up with some recommendation to the Swiss government, and we received another chunk of money to complete the archive. And I will give you a little bit more information on this. But Switzerland, as you may know, it's a small country, so we are lucky. So we just need 8 Landsat SIM to cover the entire country. So that's pretty cool. And here you just have the number of observation per month during the five years that we studied during the feasibility study. So you see the evolution of the different data sets that we gather across and we ingested in the DataCube. So this is just a quick example that came out from the feasibility study. So we ran the water observation from space algorithm, and you see we identify already a few issues. So we found the water, so all the lakes that we have in Switzerland, but we have a lot of mountains across the country, and all the shadows, for example, of the mountains were identified as water. So this is an issue that now we need to solve, or at least to improve the algorithms so that we can solve this issue. So we run also, for example, the custom mosaic tool also over a small part of the country as well. So it works fine, and we were happy with that, and the Swiss government too. But one of the key recommendations we came up with to the Swiss government is really the key for reducing the burden on EU data users is to get those analysis-ready data. And we identify some challenges. So coming from the Landsat SIM discovery and availability, Landsat SIM access, the pre-processing, the data storage strategy, so it also might be a big issue, and obviously the computing performances. So we described all these challenges and the lessons learned on generating analysis-ready data in a paper that has been accepted last week in the Big Earth Data Surface Reflectance product. And this is what we ingested in the cube. So what we did, basically, we have a chain of WPS services that allows us to gather the data not only from the USGS, because we benchmarked different data providers, and we realized that Amazon and Google were much more faster to download the entire archive of Landsat than the USGS. So we use all the data sources so that we can come up with the best available archive covering the country. Then we obviously discover the data, access the data, pre-process the data, and store and ingest the data within the cube. So basic assumptions. So we realized that the ESPA cannot be fully automated, so you need manual ordering of the images. So that was a barrier for us. We realized that the USGS pre-collection was not up to date. The USGS collection was not fully back processed. And then we also realized that Google Earth Engine and Amazon Cloud were almost complete. So what we did, we used all these data sources for downloading the data. So for the pre-processing, so we use the GS util. This is a Google tool for downloading the data. So we use fmask for the cloud and the cloud shadow mask, and for converting in surface reflectance. So far we use ArcSci. But one of the benefits of the approach that we used in this processing chain, and especially using the OGC standard, is that we are able to change those models or those pieces all together quickly, so that we can also accommodate the, well, if you have a new atmospheric correction algorithm, so we can implement it directly in our processing chain. So that's for us a key incentive. So these are just the scripts. So we use R and Python as the basic programming language for doing these pre-processing steps, and then we publish them as WPS, but internally. So it's not publicly available at this stage. So now, until today, so the Swiss Data Cube is complete. So we have more or less 4,000 scenes, Landsat 5, 7, and 8, covering the country between 1984 and 2017. So now we're setting up an automated procedure so that when we have new data within the archive, we pre-process them and ingest them automatically in the cube so that we have an up-to-date cube as well. We're also working on Sentinel-2 data, so we just started to ingest Sentinel-2 data in the cube, and we are brainstorming also on a few things. For example, the type of product we want to generate using Sentinel-2 data. So these are also an impact on the way we will ingest the data. And we're discussing with some colleagues from the University of Zurich that are experts in SAR imagery, and we are going to ingest also Sentinel-1 data as well. So I would say by spring next year, we will have an entire archive from Landsat, Sentinel-1 and Sentinel-2 data covering the country. So just some quick example on how it works. So you are quite now familiar with the Open Data Cube web interface. So we just run a custom mosaic on 1/3 of the country. So it's just 20-minute processing on a small server on our premises. So this is the kind of first result we receive from our students that are using the cube also in terms of identifying potential good applications for us. I have a student that has started just to work on snow cover and glacier mapping across Switzerland. So that's also a big issue for us, especially if we are thinking about climate change. So we are really sensitive. So most of the water that flows in Europe comes from Switzerland, from the mountains of Switzerland. So we have an important role to play in that area too. We're also working on land cover change mapping. So this is just to show you. So this is the city of Basel in North Switzerland, and you see some major changes in some of these agricultural area, but also around the city as well. So that's something that we're just starting to investigate, and we're engaging with the Swiss government to identify who are the key stakeholders that can use the Swiss Data Cube and that can benefit from that. So basically, all the offices will be interested, but one of the key issues that we have in Switzerland to find out this kind of thing is that due to the fact that it can benefit to the entire government, no one single office is interested to pay for the others. So that's a really sensitive issue for us at the moment, but we have good discussion and we'll find definitely a way to go through that barrier. So one recommendation using the Data Cube and trying to develop products for the Swiss government is that now we are a little bit struggling with I would say with the Python API and the web interface, trying to find the good documentation. So I know that's it's an ongoing process, and we need to improve a little bit, have some tutorial and capacity building material as well, so that we can enter more easily, for example, in programming with Python. And one suggestion, this is just an idea that I put on the table. So we developed already a few years ago, but we are maintaining this bringing just services into practice workshop. So this is a virtual machine that are trying to explain, well, we have a virtual machine plus a big tutorial explaining the benefit of data sharing using SDI technology and OGC standards, so answering basic questions, how can I share the data, how can I document the data, and so on. So maybe we can have a similar approach, but coming up with bringing Data Cube into practice tutorial or something like this. So this is just an idea at the moment. So regarding the potential applications, so we are already discussing with some colleagues at the Swiss government. So these are the potential applications that we are looking at. So especially there is a strong interest about snow cover mapping due to the fact due to the sensitivity of climate change across the country. But these are quite of the common application that we can set up on the Swiss data cube, on the cube as well. Also, one of the key issue that we wanted to tackle with the Swiss data cube is this link between the essential variables, so mostly essential, in this case, mostly essential biodiversity variables, and the link with indicators framework such as the SDG. So we are also, one way to go with the Swiss government is to link and to use the data cube concept to try to see how we can use this observation for the SDG monitoring framework as well. And finally, we're going to have an hackathon next year, probably in spring, late spring, during our weekend. So we'll bring a lot of geeks at the university, and we'll see with them, and we'll ask them to develop some demo product for us and to engage with them, so that we can have also a community of I would say not only a developer but users or advanced users not being part of the Swiss government. So this will be probably quite helpful for us also to accelerate a little bit the generation of some product for the government and to showcase the benefits of the cube. So if you are interested to see the progresses that we are doing with the Swiss data cube, you can go on this website. So it's just a demo for the moment. It's just a demo website, but we're slowly improving the website as well. And just to finish, Brian already mentioned it yesterday, but we've been engaged also with Georgia and Moldova to support them in the process of building data cubes, and now we are engaging also with Armenia. So in the case of Georgia and Moldova, we just received also a small amount of money from UNEP for showing the benefit for biodiversity and ecosystem services monitoring across Eastern Europe and Caucasus. So this is a really demo product. So we are using one Landsat scene within each country. This has been a requirement from the countries themselves, and we are hosting for the moment the data cubes on our own premises. But the idea by the end of the project is that that the two countries can set up the data cubes on their own premises. So basically, we'll just transfer the content of the data cube to them. So we identified, well, some of the issue, for example, this gap in terms of data availability that we identify in Switzerland in the early 90s. So we identified it also in Georgia and Moldova. So that's it on that side. Thank you for your attention. And really, again, Brian, thank you to you, your teams, CSIRO, Geoscience Australia.
Presentation. One of the things you mentioned was needing some tutorial help with the UI. Is it the installation of the UI or more of the actual use of the UI?
More the use.
More the use.
Yeah,
okay.
More the use. Yeah, the installation was quite okay. Now we have documentation, so we'll also definitely contribute. Also.
That'll be one of the things we're going to target this afternoon in our session is working with that UI and playing with it and having.
So I will send you probably by the end of this year. So one of these students just taking every algorithm, single algorithm, testing it, and identifying some issues, and then we will forward it to you so that you can have a good idea.
Another question on your data source. I know that you struggle a bit with downloading data from various sources, and sometimes in the cloud or going directly to the Landsat area and then Copernicus. Have you found the cloud to be an easy way for you to access that data and getting it through either Google or Amazon? Has that been easier for you?
So in the paper I was mentioning, so we benchmark the different data, what we call data provider, but Google is not a data provider, but yeah. So we benchmarked the different solutions, and we realized that Amazon was the best one. Definitely.
Even for the Sentinel data?
Yeah, even for the Sentinel.
Yeah, I'm seeing that as well. It more or less depends on where you are in the world. You know, just sort of your internet connection and all of that weighs in to what's the best choice. I find that the European scientists directly connected to the Copernicus hub, you know, within that zone, tend to find Copernicus hub is perfect for them. But, you know, even in Greg's case, he's in Switzerland, you would think, being so close to the Copernicus hub, that would be the ideal place. But Amazon, he found, was more efficient.
Because the Sentinel data is really, really slow. Yeah, we had big issue with, so we decided also to go for Amazon and Google, so that we can also ensure that we have a good archive.
Do something similar, Greg, in every year we have a DataCube meeting in Australia in February timeframe, conveniently, because it's their summer. But Trevor will tell you, we have had a hackathon of sorts with some of the developers in a similar way. But be very interested to hear more about your plans for the hackathon, whether we might be able to participate with you.
Sure.
Because I think it's a golden opportunity to get the users' thoughts and opinions on what kind of products are they producing and how can we make these things more efficient. That's an exciting endeavor. Great.
So the tutorials you are talking about from the user's point of view, the usability point of view, did you think about redesigning some of the parts of the UI to be more intuitive so that the burden is not on the users?
Well, the idea that we have in mind, so the vision, I would say in the coming 2 years, the UI will use it, I would say, more or less internally for just our own work, daily work. But really the idea is to have tailored products. So that's why I was also mentioning the Python API. So this is what we're investing a lot at the moment, because for us this is the key enabler to develop this kind of tailored product for the Swiss government, but also for the other types of users. The UI is really interesting. That's really a nice product for just, I would say, raise awareness about how to use the DataCube. So that's just a perfect tool. But then if you want to really go in that direction, and especially the direction of developing indicators for a country and so on, so then you have the need that come up of having tailored products. So that's why we're working definitely on this. And just remember what I wanted to say. So regarding the computing performances, so far we're just on, we have a small computer, so a small server, so it's just 64 cores, and I don't remember exactly the memory that we have on the server, but this is really a small capability. But we engage also with the University of Geneva, so we have an entire cloud infrastructure at the University of Geneva, and the aim, so we engage with the computer scientists at the university, and they are investigating the best way for us to push the cube on that infrastructure of the University of Geneva, and then we'll provide a kind of services for the entire research community and in Switzerland and the Swiss government.
Okay.
Maybe it's more of a commercial question here. Do you have, or are there any talks about allowing companies to use the Swiss DataCube for commercial purposes?
So we just started, we had a discussion last week with the first so a company in Switzerland, in Zurich, they just approached us and said, wow, that's a nice concept of this Swiss DataCube, so let's have a look and say, oh, come to Geneva and let's discuss and let's see how we can go in that direction. So definitely, but in our vision, first we want to answer the needs of the Swiss government, then doing a little bit of research, but then opening the door slowly but surely to the other types of users.
Good morning, everyone. So my name is Miguel Morgado. I'm a senior system architect at RIA. Today we'll be talking about our drought and flood mitigation service project in Uganda, and a little about how we use the Open DataCube during this project. So a little about RIA. RIA headquarters in Belgium, and we have office around Europe. I'm based in the UK, and we have an office in Canada as well. And focus in different areas, range the cloud computing solution, space systems and application, professionals, engineer service, working for ESA and for Airbus. So a little about the project. So this is a near 7 million pounds project funded by the UK Space Agency. The project is led by us, RIA Group, and we partner with international partners as Uganda Ministry of Water and Environment and other Uganda departments, and we have specialist partners as the UK Met Office to provide all the climate data used for the project, or Earth observation specialists as environment systems and pixelytics. We have NGOs in the terrain working with our final users, basically. We expect to have a CAPA version in February 2018 and the pre-operations around March 2019. So that is kind of startup project. In March we need to put all together the team, the architecture, all the process, find out which direction you go, for example, to store the Earth observation data, work in terrain with our partners and main stakeholders. Main focus is the people actually that will be using the data. For that we conducted group discussion meetings in Uganda with different stakeholders, could be Uganda government or farmers. We train people actually, they will be using the system. 135 farmers involved and 75 shepherds. I know it don't look a lot, but is the people actually will be most impacted by our project coming from this project. The main one is improved crop production and livestock health, so improve crops and providing the right information to farmers in the right time. So with respect to drought to happen or a flood, they can in advance decide which seeds they want to use, or move livestock for a higher place in case of flood forecast. Area, so this area here, northeast of Uganda, near Kenya, which is one of the areas is most affected by droughts and floods. You'll use Earth observation data directly, or derived data plus climate data to provide early warning platform to the national the people that actually decide nationally what to do in case of drought or flood. Now a little more technical. So our project to include the visualization part, a website, application, and API. We are doing the visualization, the website part and application just as a proof of concept. It's not our main goal to create a visualization tool for our projects. So the idea is to people in Uganda, and again this is called DFMS Uganda, that all our project is open source. Stream is a part of 6 Square offer. 6 Square is a real company as well. And we work as a cloud broker if you want. So we are not locked to any cloud. So we deploy the DFMS or Open Data Cube as a app in our slipstream, and then the user, the government institution decides where they want to deploy. Could be AWS, could be Microsoft Azure, Google, any other cloud, and will work. It's all automated. So in terms of in terms of Open Data Cube, we created a Docker container for Data Cube. We find out it's kind of difficult to get the first one, but since you know the first one, then it's much easier. So we create a Docker container. So as mentioned, our project is open source, so everyone that want to request our help, we are in 12, everyone interested. Open Data Cube, a big thank you for NASA, Australian Science, and the Open Data Cube community. So big help. They are great supporting. To be fair, when you know the basics, then it's really easy to deploy Open Data Cube. Ingesting data was kind of easy because the Geoscience Australia did the heavy lifting for most of things, and we received lots of help from Catapult UK in terms of ingesting Sentinel-1 data and Sentinel-2 as well. So great help in terms of why you decide to go to Open Data Cube and not other solutions available in the market. So early days we decide our project will be open source, and you want our approach for this project, while we are a commercial company, is to share and then be open enough, and it's possible. This model, Google is one of the most powerful companies in the world, and most of their products are free. So I think sharing knowledge and sharing everything is important. We received lots of help in relation to Earth observation data. My team in UK, I don't identify ourselves as Earth observation specialists, more developers, so more the IT infrastructure side, despite you have partners here that have the knowledge about the Earth observation. But we received lots of help from Australia, for example, initially, and I hope now we can go back and give you something back, so our work related with the climate data ingestion, and we are keen to share that back to Australia or to any other. I think that is the spirit. So, can you see? So, in terms of data, we are ingesting Sentinel-1, Sentinel-2, Landsat, SMOS, and Sentinel-3. We have not started yet with Sentinel-3, but we will do it. All this data is ingested in the Open Data Cube. From there, we derive data, so NVDIs, soil moisture, water stance, land surface temperature, and so on. We have not done all yet. We ingest around 60 terabytes of data up now, so it's not like a big amount of data. So the difficult part is moving data around. So we are using clouds. So currently, at the moment, we are using AWS and Microsoft. So all the data is stored in object storage. And we move data, so we create our own. If I knew it, I could ask you like 1 month ago. Now it's too late. So we create our own process to move data around. So when new data arrive to a bucket, the system identify, move, and process, and then move and move and move, storing the different buckets till it arrives to in the end of the process. Look like simple, but in reality, moving this data from in the backend. However, to start showing something to our main stakeholders in Uganda, we need to create some visualization tools. So we are using GeoServer to move data from the data cube in NetCDF format to front end. And we are using WMS, but in reality, having GeoServer could be any OGC standards if you want. So we create a front end where you can search for data. And really, the first version just show different data sets in a map. Again, these will be probably the users of this kind of interface will be like probably 5% of our system. So the Uganda Met Office probably will use that, but not farmers. So a big part of our project is disseminate the information. And believe me, it's not easy to go to Uganda and make the information reach all the areas. So lots of areas don't have, most of areas we don't have internet or computers. So how we disseminate data then? So we have partnership with the Uganda government to be main point of contact for everything. But then you have the NGOs in the terrain, passing schools in the local communities, a printed report with the seasonal forecast, so really easy to read in local language and English, with some are just image showing you have some problems with the logos. For example, in case of heavy rain, if you use like a spark symbol is not well seen in Uganda, so you need to be careful the cultural aspects of it. So, but we have this interface to show what we are doing in terms of data, despite it's not our main goal, the visualization part. So it's more the processing the data. Any questions to now? Okay. So talking about the Open Data Cube implementation and suggestion. As mentioned, ODC community really great. All support provided. Everyone was really helpful and really easy access, and the answers are really quick. So I don't know in your case, but in our case we use Slack, kind of Skype for developers, where you can exchange messages and files and so on. So the Open Data Cube has a Slack page, group, yeah, Slack group, yeah. And then I think inside the group is subgroups, so you can ask really specific questions about specific areas. And it's really easy, so the developers are there and they don't need to go to manager, and then manager talk with someone in Australia or NASA, and then back and forth. They just go there, post the questions, I have this problem, this is not working, and someone, when they wake up in US, Australia, or whatever, oh, this guy has a problem, and provide the answer. Most of times the answer is really quick to arrive. This guy did the heavy lift for most of the basic stuff. It really could help. The GitHub repository is really good as well. I only can say you have some difficulties at beginning to identify the right repository to download data and to deploy, but I think it's getting better. So all these Open Data Cube community is getting stronger and improve the process.
With this collaboration, are they working with any university?
No.
Did the administrator work with any university?
So, as far I know, so I'm not connected to Uganda government directly, so we have the project manager and the business developer team working there, but far I know we are not connected with any university in Uganda.
Or not?
Probably in the end if I have time.
Yeah.
Okay.
Any other questions? Yeah, there's another.
It's Philip. I advise the presidency, but also the advisor to the Minister of Agriculture for Kenya. I'm more interested in terms of the intermediaries, because this is very complex data. So how does it get to farmers? And do we work with young innovators? Because we are aware of some other innovations, for example, like you report, that people engage with, like UNICEF.
Yes.
So I'm quite interested in terms of how does this information get to the farmers, and can they afford it? Because farmers like Kenya and Uganda are mostly small-scale farmers.
So, okay.
So one is affordability. Secondly is how is it dummied down, sort of, because it has to go granular, right? And farmers a lot of them are illiterate. So how does this all make sense to them?
Yeah. So first of all, this is open source. We are not charging $1 for it. So all the data will arrive to the farmers.
You don't have to charge it. The telco charges, right? So I'm looking at the cost. So have you? That's why I said maybe. So have you had conversations with the telco?
So this is a sustainable project. So after 2020, the project needs to be sufficient, if you want, to all these machines to work. So we are working close with the Uganda government to find ways to finance it, and commercial companies like the sugar company, cocoa, and so on. Lots of people are interested in that. So how they reach the information to the farmers, so be it government and these NGOs that already work in terrain with people.
See, I'm giving you a brief case example. Maybe there's something you may want to think about. Because, for example, in our case, we have the same massacres and the rest, but my role sees that they do not necessarily have scale that the government has in terms of reach, because NGOs by themselves also require some form of sustainability. So they're not everywhere. So that's one.
Yes.
So, and that's my point. So how do you engage with telcos who are everywhere in that sense, right? Because the penetration in Uganda, like Kenya, is almost 100%.
Yes, almost same.
Exactly.
So it's a difficult question how we reach everyone. So we had a couple of meetings with groups. So our main focus at the moment is Karamoja area. So we want to scale up to all Uganda till the end of project, so 2020. So we are working with the Uganda government to find solutions how to do that. I don't know the answer to your questions, but I believe if you have same problems, will not be something simple.
For all of the forecast data, we are trying to work with the National Meteorological Agency of Uganda. For all the early warnings, we're working with the NECOC, which is basically the people providing early warnings for the fall. So we're trying to go through these existing organizations to try to basically provide NSL kits to those people, to those organizations who have the knowledge on how to transmit this at more local level.
Okay.
Rosanna Rivera from Colombia. Take it away.
Hello, everyone. My name is Pilar Lozano. I work for the Hydrological, Meteorological and Environmental Studies Institute, what is attached to the Environmental Ministry, the scientific institution for the environmental information, the environmental ministry. I work for the Forest and Carbon Monitoring System, so I will share to you our advances and experience of the Open Data Cube and the implementation of the Open Data Cube, which is in frame of the Forest and Carbon Monitoring System. Colombia is located in the northwest corner of South America. We have more than 2 million square kilometers. Colombia is covered for 65 Landsat images. This is an example of a cloud-free mosaic that we have been using for the reports of deforestation rate that we have to publish once a year. The Forest and Carbon Monitoring System is focused on 4 topics. Early warning, that is based on MODIS image. That is a quarterly product, 4 times a year, and is focused on identifying the hotspot of deforestation. The national quantification of deforestation is based on Landsat image. It's a product that we produce annually, and it's a map of the scale is 100,000. And we work also in the deforestation and degradation drivers with characterization and modulation, and we are implementing a national forest inventory for carbon monitoring. Well, I would like to talk about a little background of our experience on the Open Data Cube. We start with a pilot in 2015. We used the version 1 of the Australian Data Cube. In this year, we ingest around 1,500 images for a small area for 15 years, and we implement a couple of algorithms. In 2016, we used the second version of the Australian data cube, and over this version, we built our bank of algorithms. We implement user management web interface. We work in a parallelization strategy. We also code bulk of ingestion, and we also work in some trainings workshop, and we did a massive ingestion. And this year we are still working in scalability and new algorithms. So we think when we start thinking in our own data cube, we were thinking in some goals. So we wanted to be the ownership of our data. We wanted to add and code new algorithms. We wanted to use different sources of data of observation. We wanted to be sure our lineage, our data. We want to enforce the replicability. We want complexity abstraction. We wanted to publish our algorithms. We want a good usability, easy way to the user to use our data cube. We want to work in the parallelization of the process, and also we want to feed our own standards, our IDEAM standards. Means that we wanted to continue our operation of the forest and carbon monitoring system. So we make a simple analysis of the other big data, air observation big data tools that we can use. And this is our results. We have things of other tools, but we are focused on our own goals. We download more than 20,000 images, and we ingest the tier 1 catalog, that is more than 60,000 images. This just to point out that these files outside of the data cube is around 17 terabytes. Using the data cube is around 4 terabytes. So we are optimizing our storage information, our storage infrastructure. Also, we work in a web interface that if I'm lucky, I can show you a demo. And we made some workshops for capacity building, and we work in some applications that I'm going to show you some examples. Well, about the user, the type of user that we have in one interface, our data cube. We have a system administrator that it is the highest user. That is, he has is in charge of the operation and the good operation of the data cube. We have a data administrator. Is in charge of the governance of the data. He decides what images are ingested, what is also in charge of the permission of the new users. And we have these two that those are operating actually the data cube. The developer is able to create their own code in Python, and the analyst is able to use the algorithms that are published by the developers. So our bank of algorithms has algorithm version execution. What happens when the analyst choose algorithms to create a new product? He selects the algorithms, he selects the version of the algorithm with the parameters. He submits the execution, and the data cube record the execution, split the execution by tile, and execute the task to deploy the results. Then the analyst receives the list of executions, and he can download the results in NetCDF or GeoTIFF. And then the DataCube delete the result for a time period of time. What we have developed when we are working still in some of these algorithms, but we can't create a free mosaic temporal median composite. That is the base of the forest and carbon monitoring system products. We also can't create an index for vegetation for snow. And classification, we have been working in forest and no-forest classification. It's a basic classification. Also, we have implemented the change detection based on principal component analysis, that these algorithms compare 2 years to actually it's 2 temporal median compounds and identify in one component the difference. Also, we have been working in unsupervised classification, using a Cummings clustering and the random forest as a supervised classification. We adapt the water observation algorithms from the Australian data. So I will try to show you now, if I can, our interface. So just to show you a little bit, it's working. First, it has a manager user, so the user can look at the image that are stored in the data cube and can create their own algorithms and can run the algorithms. This is a screenshot of the way that the data cube interacts with the user to get the parameters that are the data, the area, and the parameters that the algorithms itself, and all of the information, geographic information, scale, etc. So we have provided these templates to create the new files for new storage unit. Also, we have scheduled the ingestion for a low work time period of time. I mean, you put the image that you want to ingest in a folder, and the data cube understand that the ingestion it will be 2 a.m. or 3 a.m. when no one is working at the office. And this is an example when you can create a new algorithms. The advantage of this tool, or this part of the tool, is that the programmer or the developer don't be worry about the call of the data. You have to be only worried about the operation that you want to do with the data. So you have to create your own code. You put the link of your GitHub, and the data cube bring the code and put into the data cube, into the bank algorithm. Well, I think that's it. We work in the parallelization strategy based on Celery, divided the tasks by tile, the one grade by one grade. So our components are based on the Open Data Cube code, but we have the ingestion scheduler, the execution management, the bank algorithms, and our REST backend, our web interface. This is our data cube, and now I'm going to show some we call sexy results, because this is the kind of information products that my boss likes, and because they can, he was very happy with this result because this is a very ecosystem important area in the Caribbean of Colombia, because it's communicating two important cities, Santa Marta, Barranquilla, and in the this year we start working with an index for snow. This is a Nevado del Cocuy, and we start working with this because we have to remove the CF mass actually. Here I compare to very long period of time, 2000 and 2015. So the algorithms is able to identify where the two components or two mosaics are different. Change data. You have any